Hello, everyone. Thank you for joining us. On behalf of the Environmental Finance Center Network, I'd like to welcome you to today's Ask the Expert style webinar on capital improvement planning. My name is Tess Clark. I work here at the Syracuse University Environmental Finance Center. And before we get started, I'm just going to quickly go over some logistics and some information about our network and about our work. So first, some logistics. During today's session, everyone will be on mute to ensure audio quality. If you have a question, just type it into the GoToWebinar question box at any time throughout the session. This is an Ask the Expert style workshop, so we are here to answer your questions. Some of you submitted questions in advance and we'll cover those, but we will also have an extended Q&A, so if you have questions, go ahead and send them in. If you're having technical difficulties, feel free to also use that question box and I will do my best to help you. We will be making today's slides available as well as a video recording on the EFCN website. You can reach that website at www.efcnetwork.org. Please allow 2 weeks for the processing and posting of those materials. As a courtesy, we like to provide a certificate of attendance for participating in the webinars. This webinar has not been submitted to licensing agencies for pre-approval of continuing education credits. You will need to check with your agency directly if you're interested in receiving any type of credit, and you must attend the entire 60-minute session by logging into GoToWebinar with your unique link in order to receive a certificate. If you watch the webinar with a friend and you're not directly logged in, we will not have a record of your attendance, so we can't send you a certificate. So please do log in and we will send your certificate via email within 30 days, and you can keep that for your records or use it to document your own education. This webinar is one of several that we conduct here at the Environmental Finance Center Network for our Smart Management for Small Water Systems project. Through this project, we provide training and technical assistance to small public systems in all U.S. states and territories to help local water systems achieve their goals and also stay in compliance with the Safe Drinking Water Act. And here you can sort of take a look at our small systems team. Our network is national with a center in most U.S. regions. Today you'll hear from our staff at the Wichita State University EFC, as well as me. I'm here at Syracuse. And here you can see some of our areas of expertise that we focus on. We provide workshops, trainings, and direct technical assistance on a variety of topics listed here. So you can see things like asset management, energy management, workforce. We also will be talking about capital improvement planning. And on that note, we'd like to start out the program today with some polls. These polls are about CIP, which you will hear more about throughout. So our first poll is, does your water system have a capital improvement plan? Just tell us yes or no. If you're unsure, you can tell us that as well. I'm going to give you a couple more seconds just to respond here, and then I'll go ahead and share our results. Okay, I'm going to close this one. Okay. So 58% of you said yes. We still have a strong 30% about that say no, and then 13% are unsure. And then next, just have a couple more of these. If you have a capital improvement plan, how many years does it go out? So if you think it goes out, if it's about 0 to 5 years, tell us. If it's 6 to 10, you can respond that in that direction, 11 to 20, and then we even have an option for 20 years or more. And again, just running through these pretty quickly, so we'll close this in about 3 seconds. Looks like most of you have responded, so 2 and 1. Gonna close this one. And it looks like 63% of folks on the webinar today have a plan going out 0 to 5 years, 8% with 20 or more years, and then sort of in the middle, we have 30% with 6 to 10 years. All right. And this is a question about if you have a threshold for capital improvement. Just say yes or no here. Or if you're unsure, tell us that. I'm going to go ahead and close this one. It looks like most people have responded. Looks like 46% of the people on the webinar today, or the majority, say yes. All right. And then lastly, if you look back over the past few years, looks like most of you are responding. So I'm going to go ahead and close this poll and share the results. Okay. All right, and on that note, I want to go ahead and introduce Nick Willis. Nick is a program manager at the Wichita State University's Environmental Finance Center and also a licensed professional engineer in the state of Kansas. He previously worked at the Arkansas Department of Environmental Quality and has also worked on wastewater and stormwater utility management at the city of Hays in Kansas. So welcome, Nick. I'll let you jump in here and talk about the polls and talk about the Ask the Expert webinar today.
Okay, thank you, Tess. We will dive right in. I'll present a little bit about what capital improvement plans are. This is something that Wichita State and the Environmental Finance Center offer as kind of day-long training, so it's very condensed within this, but we'll get right into it. So the first question you might have, if you're unfamiliar with capital improvement plans or if you don't have one in your utility system is, well, why would I want to create a capital improvement plan? When we look at drinking water utilities, there's two things that really come to mind as the primary drivers. First is regulatory compliance, which generally
I think we can't quite see the presentation yet. If I'm not mistaken, can you let me just make you the presenter again so that you can see it.
Sorry about that, guys.
Yeah, I'm gonna take it back for a second. It looks like it just froze.
Got it?
Okay. All right, so you should get that. There it is. Perfect. Thanks.
Okay. So the reasons for creating a capital improvement plan, public health and safety and compliance with Safe Drinking Water Act and state and local regulations, which may govern your water supply system. After you get those two things in line, you look at other good reasons, such as coordination of projects. Much of a water utility's infrastructure is buried under other infrastructure, so things such as coordination of street repairs at the same time as water utility upgrades and repairs to go on. Capital improvement plan, the process allows you to also better organize and prioritize both the needs of the system and the desires of the system and how it interacts with your community. It also allows you kind of another process to make sure you're doing your due diligence, to make sure you're holding your consultants, your engineers to a high standard of performance, that they're evaluating appropriate alternatives and things like that. The picture you see here on the right side of the slide is the Oklahoma-Kansas border. On the north there is the Kansas Turnpike terminating into a wheat field in Oklahoma. Clearly, some coordination was lacking, and anytime you get multi-jurisdictional capital improvements, which some of you guys may be involved in, coordination becomes ever more important. So what is a capital improvement plan? There's really no formal definition, and if yours looks somewhat different than what I explained to you today and it's working for you, great. Don't worry about trying to change things up. Fundamentally, it needs to be a document that works well for your system. Generally recommended by the Environmental Protection Agency is that it will cover at least 5 years of capital needs going forward. Some utilities are looking as far out as 100 years. Realistically, for most small utilities in this country, that's probably not super reasonable. But somewhere between 5 and 20, and from the poll results, that's kind of what we were seeing, is pretty standard. Your capital improvement plan should detail the costly projects and or equipment that your system is going to be installing and or purchasing. Each of those projects should have some degree of detail on financing for them and also time frame. Justification of project should be in there as well. Why do we need to upgrade this water line? Why do we need to make changes to our water treatment plant? Things like that. You should have good justification for the expense of those dollars. Most capital improvement plans are non-binding, particularly if you're planning several years, 5, 10 years out in the future. Life's going to happen, things are going to change. but it's still good to have a plan over time. Generally recommended is to update them annually. What goes in? We did have a question on a price threshold, whether or not a project is considered a capital project. Generally speaking, this is some arbitrary number determined by the water utility or the municipality. Sometimes it's related to the purchase authority of the senior-most employee within the organization. Physical assets should go into a capital improvement plan. So the infrastructure stuff, because your pipelines are often under streets, those have been included in this. Major equipment, anything dealing with treatment of water should also be included in capital improvement plans. The question of intangible assets comes up. So let's say your water utility is doing a treatment study or a water distribution model. That may cost tens of thousands of dollars sometimes. Do you include that in your capital improvement planning from an expense threshold? Yeah, you probably would. However, there's no like physical asset you can point to and say, well, this is what we got for our efforts. So that's a question you may have to ask going forward. I've seen it treated both ways. Fundamentally, you're going to have to pay for those intangible assets one way or another. So including it, if including it in the capital improvement planning efforts is part of it, that could be a way to go. When you're looking at things, projects and equipment, whether to include or exclude from your capital improvement plan, typically you'd want to include things like capacity expansion. So adding a well to your well field, increasing pumping capacity, improvement of treatment. So you have expansions, upgrades. If you're taking out infrastructure and replacing like with like, so replacing an old water main with a new water main, that would typically be included in your capital improvement plans. You also should include first-time new purchases. So there's a lot of expensive equipment out there that many utilities have or many utility operators want to have. So you might buy a valve exercise trailer. That's going to be, tens of thousands of dollars. Certainly the first time you buy it, that would be a good idea to put it in your capital improvement plan. However, going forward, for those expensive replacement items such as a truck, a motor, or equipment, you might want to include that in a separate equipment replacement schedule and not in your capital improvement plan. Again, if you're doing that with your current capital improvement plan, it works. There's probably no need to change, but if you're setting out a new capital improvement plan, you might want to develop an equipment replacement schedule as a separate document. So many people on the line, 30%, did not have a capital improvement plan within their water utility. So some helpful hints to beginning it. It should reflect the values of your community. Most water utilities are attached to a larger municipal or county government in this country. So you can't escape that, and it's best to play along and go with the broader community planning efforts as a water utility as part of your municipal organization. Your capital improvement plan should reflect the desires of multiple stakeholders and make sure you meet the needs of the critical facilities within your town. Depending on the size of your utility, the size of your municipality, your capital improvement plan should incorporate other plans that you may have and goals of your community or utility system. So you might have a utility master plan. You might have boundaries for a rural water district or a municipal water supply that you have to stay within. You have also things such as financial policies or state laws that can govern your capital expenditures, the amount of debt you can take on, things like that. If you're in a metropolitan area, things like comprehensive plans and regional planning organizations will play an impact sometimes on your capital improvement planning. Obviously, again, regulatory demands, if you know that there's a regulation you're not going to be able to meet, be planning for that within your capital improvement plan. And also cooperative agreements. You might be a wholesale purchaser and or a wholesale supplier to other water utilities. Ensure that your cooperative agreements with outside organizations are held up within your capital improvement planning. When you're looking at specific projects, so basically a capital improvement plan is a bunch of different projects that go together to make a single plan. So when you're looking at specific projects, some of the best practices, and again, if you're doing more than this or somewhat less than this and it's working for you, keep at it. Generally, some best practices, have a standard project sheet so that everything kind of looks the same in your capital improvement program. Some things you might want to include, obviously the justification and cost. What will this project do to your operation and maintenance? Is it going to increase labor and electrical demand, decrease, or really have no impact? That sort of long-run cost is important to include. It's also important to note that while you as an operator or you as a utility manager might intimately know your system, your board members, your city commissioners may not. So things like pictures and maps and sometimes even explanations of what this is being utilized for are beneficial for the decision makers and also community members. You might also include priorities. This is a really high priority capital improvement item. We need to do it soon. This is a lower priority capital improvement item. If necessary, it can be delayed. Regulatory impacts are also important. Certain treatment technologies, such as reverse osmosis, may open up new regulatory demands because you have to dispose of that wastewater, where what you may be doing right now doesn't have a saltwater disposal issue. So ensuring that you kind of give people a heads up as to, hey, we might be entering new regulatory areas that we aren't previously in by doing this capital improvement in this way helps people do their due diligence when they're reviewing these various projects. This is what a project form may look like. This is from the 2017 Hays, Kansas budget. It was a project I actually had put together back when I was at the city, and it does a lot of these. Why do we need this project? Most people wouldn't know why you have carbon dioxide at a water softening plant, so you kind of have to cover that within your project sheet. Has some impacts on budgetary, and it also justifies the project. Basically, the environment had changed, and our delivery system of carbon dioxide to our plant was different than it had been when the original tank had been installed, and there was a strong indication that a larger CO2 tank was needed so that we could, produce water on the highest demand days. So now we'll get to the questions that came in before this webinar. The first question we got was a good one. I'm interested in how to begin. Our mutual water company is very small, 47 hookups. So this is a good question for those who may not have a capital improvement plan. I'll reiterate, regulatory compliance is really where you begin. So if you are a water utility that's out of compliance with the Safe Drinking Water Act or some state or local regulation, that's probably the first capital improvement plan you really need to be, capital improvement project you need to be looking at. Likewise, if there's some sort of safety hazard to public or the employees of the utility, that would be another good starting point. Secondly, you'd look at critical assets in high in priority or high risk. And I'll be talking about this in the coming slides. The other main area that you might consider first are those assets which are financially impactful. So if you have water meters that are only recording 75 or 80% of water going through, that makes a big impact on your utility financially. You might consider that being a high priority capital improvement because it will improve your system's finances by replacing those meters, getting a more accurate depiction of customer demand and billing accordingly. Likewise, you might have very inefficient equipment within your utility system. Upgrading that inefficient equipment, reducing energy and or chemical usage can help free up funds to do other capital improvements within your utility. So think about the financially impactful ones, the regulatory compliance, and we'll talk a little bit about critical assets on the next couple slides. The idea of figuring out which assets are critical to your system really comes from asset management planning. Fundamentally, not all assets are the same risk to your utility operations. And you can estimate risk of your assets through what they are, your experience with them, and estimating the consequences of failure of those assets. So when you're estimating the risk of your critical assets, you look at the probability of failure. That's the horizontal axis on this slide. And you can say, well, this asset has been causing problems for years. It continuously causes problems. That would be a very high risk of failure. A low risk of failure might be a brand new asset that doesn't have any moving parts, such as 2-year-old pipe in the ground or something like that. Your consequences of failure are both to your utility's bottom line, to public health, and to your community as a whole. So this would be something that's very expensive to replace, and or has very consequential impacts of failure. So you might be putting out, critical facilities within your community, schools, hospitals, wholesale customers. Failure would risk public health. You'd have to have boil orders. You might lose system pressure and things like that. So you would take your assets, plot them off on a graph such as this, and kind of answer your questions. Which ones do I need to assign and prioritize in my capital improvement plan first? These numbers are illustrative only on this slide, but when you're looking at investments, when you're looking at your operation and maintenance dollars, those assets in the upper left are the ones that need to get the attention first and to get more of the attention, both in capital reinvestments and in operation and maintenance. Your own system will vary somewhat from this, but it's a good screen. If you're spending 80% of your budget on items that are fairly low importance and not spending much money, not spending much on capital improvements on those extremely important higher risk assets, you might take a step back and try and reprioritize things. So that's kind of where this question ends. And as always, you can contact me after the webinar for more individualized help on that. The second question we're going to run into here is, where does funding for capital improvement land on the annual budget? Does it come out of the year's expenses or a separate fund? Before I tackle this question, I'd like to say that everybody has different rules governing their accounting systems for their utilities, and there are state level rules about various organizational structures and how they're allowed to account for things, and also how they're allowed to finance things. So this answer is going to be fairly generalized. Broadly speaking, the first thing to understand is that when you're looking at financing and budgetary impacts, is that your ratepayers and or your customers are going to pay for the capital improvements. There is a little bit of a section for grant and loan forgiveness, but your customers are going to be the people paying. The main question when it comes to financing is when are those customers going to be paying, and how are they going to be paying? So we have outside funding. Grants and loan forgiveness are, again, that exception to the rule where your ratepayers pay for everything. Grant and loan forgiveness is both rare and competitive. If you're able to get grants, it's probably a good thing to do. It's important to note that there are sometimes some strings attached to grants which can lead to higher project cost. And if you think you are a good candidate for a grant for capital improvements for your water utility, I would recommend contacting the people who administer those grant funds and see if you might be a good candidate. Outside of that, you're looking at funding sources such as the various state revolving loan funds, and for rural communities, USDA Rural Development. These are typically considered a source of cheap interest rates and pretty good terms for financing capital improvements. So you're taking on loans as a water utility here. When you take on debt, be it in the form of a loan or a bond, you are having future customers pay for your current capital improvements. So that's important to note, and that plays into the budgetary question. So your state revolving loan funds are a source of outside funding. USDA is a source of outside funding. And then municipal bonds, rural water district bonds, loans, leases, et cetera, are also sources of outside capital funding. When we look at the budget impacts of this funding for loans, bonds, and leases, again, I would ask you to check your local accounting rules, your state laws, in order to show the accurate portrayal of these in your system. So if you're paying for capital improvement with some sort of outside financing, the repayment of those bonds, loans, and leases is going to be shown as a current expense in an annual budget. Some systems will break these out individually, so they might have a line item in their budget showing a current expense as, for example, a 2008 water tower loan repayment, or they might lump them together if there's multiple sources of indebtedness to state revolving loans payments. Either way can work and be effective. So your current and future customers are paying this, and it will be reflected in your budget. If you are self-funding capital improvements, either in real time or by saving over time, that will also have budgetary impacts to your system. The first thing we'll tackle here is real-time payment. So generally speaking, small systems don't do this a lot, but medium-sized and larger utilities often do some capital improvements via cash in, cash out from the current rates and fees. So what you see with water utilities, this will often take the shape of annual pipe replacements, and it will be a line item in their budget. The utility might be annually budgeting $50,000, a couple $100,000 a year to replace several blocks of kind of standard distribution pipe in their water distribution system. So basically, their current year income is paying for current year capital improvements. That's a great thing to be able to do if you're in that position. So you might show this as a line item budget entitled annual pipe replacements, or something like a transfer to a reserve account, and then you spin it out of that reserve account. Again, this is one of those things. If it works for you, keep doing it like it is. If you're thinking about this, there's a couple different ways you might tackle this problem. You can also save up over time. In this case, generally, utility would have some sort of an indication on their annual budget of a transfer to a reserve account where you're putting the savings. So maybe a transfer to a capital reserves would be the title of the budget line item. So take for an example, you're planning a $400,000 water main replacement 10 years from now. Within this, you might show a $40,000 annual transfer over the next 10 years in your annual budget. It's also important to note that when it comes to utility financing, you can combine things. Oftentimes, projects will receive grants, state revolving loan funds, and maybe even a USDA rural development loan. You can pay partially in cash, issue a bond for the rest. There's a lot of options. These are all going to depend on your own possibilities, your own legal structure, and a lot of other things. So that's when you want to engage the appropriate professionals to help out on that. You can also phase a capital improvement project with multiple funding options. You might do phase one, might be a USDA rural development loan. Phase two might be a state revolving loan fund. There's a lot of ways to approach funding a capital improvement. The third question I'll tackle here is, how often should a water system plan on replacing pipeline? What is the anticipated lifetime of the various materials? This is a good question, and I'm going to somewhat punt it, but I will note this is a very, very important question for almost all water utilities, particularly smaller water utilities. your pipeline is often your largest asset by value. So whether it lasts 40 years or 110 years makes a huge impact on ratepayers, the level of water rates you have, the amount of indebtedness there will be against your system. And if you can make a 50-year pipe last to be 70 years without running much more risk, that's going to be a huge amount of savings for you. So I would say when you're looking at pipe replacement, doing due diligence is very, very important, both with asking the question, are we replacing the right pipe at the right time? And are we ensuring that the new pipe we're putting in the ground is going to last as long as reasonably possible? So I'll kind of cover those a little bit. Looking at pipe life, this really will vary significantly. There's a lot of miles of pipe in the ground today that's well in excess of 100 years old. And some of it may be in the ground for another 100 years. It's always tough to predict the future, but certain municipalities and the right environment have very, very long-lived pipe out there. I have seen as low as about 20 years for some distribution network pipe. There were a lot of other factors that made it last that long. The pipe itself was fine, but all the connections were done poorly. So it didn't make a whole lot of sense to dig up all the pipe, re-glue it, and then bury it again. So that would be an extreme low-end outlier, I would generally think. So pipe life will vary significantly. It's also important to note that the functionality of the pipe is what is generally most important rather than the age. So again, looking at that 100-year-old pipe in the ground, the utilities 30 or 40 years ago could have said, well, I have, 80-year-old pipe, I need to replace it. And they would have lost 30 years of service life by doing so. So they decided to keep pipe in the ground that wasn't causing a problem and not posing a large risk, they hope. So if you have pipe that's old, but it seems to be working fine, that's a good indicator that maybe it can continue to work fine into the future. Replacing pipe when it's problematic is typically the driver out there. If it poses a large risk or if it is obsolete, and yes, there is obsolescence in pipelines. It's also important to note that inspection technology seems to be moving fairly quickly, particularly in very large mains. There's inspection technology that may well be cost effective for you to invest in to ensure that, oh yeah, my big diameter pipe actually does need to be replaced. And you may actually limit the scope of the project if only 20 or 30% of it through inspection is deemed to need replacement. And that can be some very large savings to you, and also some good peace of mind by having an inspection of your large mains. And I'm talking very large mains, like 24 inches plus. You can go a long ways. It's expensive to inspect right now. There's not a lot of technologies out there. A lot of them are still kind of on patent. But look to the very large utilities nearby you. Look to your kind of water conferences, and you'll see presentations about these throughout the country. So on that note, age is not a good indicator of pipe condition. And also condition may not be uniform within a pipeline. So just because you have a bad, 100 feet or so doesn't mean the entire mile of pipe needs to be replaced. Some of the signs of failure and obsolescence. So when we look at pipe failure, frequent main breaks and or leaks are a good indication that your pipeline may be approaching the end of its useful life. If you have customer complaints about poor water quality, if you have red water in your lines, that may be a good indicator that your pipe is approaching the end of its life. If when you have done a main break repair or excavated a pipe for some reason and you see that it is very thin or that there's a high amount of corrosion, that is also an indicator that your pipe may be approaching the end of its life. Likewise, unexplained poor pressure. And the upper left picture on this slide kind of shows you what's going on here. This is a process called tuberculation, and basically minerals form on the inside of your pipe, and this can make a an 8-inch diameter main effectively be a 2 or 1-inch diameter main, and that will obviously cause pressure problems in your distribution network. Sometimes this can be alleviated and you can rehab it, but that's kind of a case-by-case basis as to whether that's the appropriate way forward. Obsolete pipe. If you have set a level of service goal for your system, that you're supposed to have a minimum fire flow at all your fire hydrants, and you don't right now, that may well be related to your pipe network. So there is a lot of pipe out there that's in good shape, but may not meet modern fire code, modern requirements for fire suppression. Oftentimes, some of that pipe is replaced in order to bring up the fire flow in the distribution network. And then there's at least kind of two technologies out there, two materials: lead, which is generally in customer service lines, but is occasionally in your distribution system, and asbestos concrete. Both of those pose some extra risk to public health, and on asbestos concrete, if there's ever a main break, employee safety and things like that. So those are signs of failure and obsolescence. When we're looking at trying to ensure longer pipe life, particularly important if you have good condition pipe today and you want to keep it that way, keeping your stresses low is important. So you want to eliminate those pressure transients. So anybody opening and closing fire hydrants should do so very slowly to prevent water hammer. Likewise, your pumps in your systems, consider using soft starts or variable frequency drives so that you don't have a very high flow hitting your distribution network all at one time. Eliminate those stresses to the degree possible. If you have very, very high pressure in parts of your system, you might also consider pressure reducing valves or other technologies to minimize the pressure on your pipe out there already in place. And when you're installing your newer pipe, ensure that you're matching the material to the environment. Soils with low pH, your acidic soils, salty soils, saline soils, those all tend to be fairly corrosive and will reduce pipe life. So make sure that you have the right type of pipe and fittings in those areas. Rocky soils will damage your pipe, particularly during installation. Ensure you have proper backfill around that. So that's keeping a good eye on your contractors, on your inspection engineering type of firms. Ensure that the pipe is below the frost line. And when you're asking yourself the question, what kind of pipe should I put in here? Talk with neighboring utilities, talk with the local technical service providers, your local rural water, American Water Works Association type people about who's having good experiences with pipe, new pipe installations, and how the different materials are working out for the different systems that are using them. So looking at new mains, basically we have pretty high quality material out there now. If you have properly specified material, pipe material that's handled properly during transit, that's inspected during installation, and then operated properly within limits, you'll have a very good, long-lived pipe network system. So I hope this has helped answer the question, and to specifically ask on a single system, you can get individual engineering companies may give you an opinion on your specific pipe network, but the answer is generally is going to vary. The final question we're covering that was submitted early is how much of a capital improvement plan budget should go towards projects providing resilience against the future effects of climate change? This is a really good question, and another one I'm going to kind of punt on. So first, we're going to look at resilience versus mitigation. I went ahead and defined these as resilience being the ability to withstand. So the climate is changing. It's going to throw these other problems at my infrastructure, at my water utility. How do I make it withstand that infrastructure? Or how do I make it withstand these new stresses? So hardening infrastructure, protecting against flood, expanding supplies for droughts, all of those are kind of resilience efforts. Climate change mitigation efforts are attempting to decrease the contribution towards climate change. So this is trying to use less energy, maybe electrifying your vehicle fleets in your utility or municipality, utilizing less chemicals, things like that will help mitigate climate change. And then there's capital improvement projects that will do a little bit of both. So water efficiency projects can do some of both. Likewise, treatment facility upgrades can do both. You can harden against power outages or wind, and at the same time make your the internal equipment more efficient within your treatment plant. So what percent do you spend on resilience? There's about 50,000 water supplies within the U.S. So this answer is obviously going to vary a lot depending on local situations. There's some systems out there that probably need to spend a very, very low percent of their capital improvement spending on resilience. Some of the things that might characterize these are areas with stable groundwater levels, so they're not seeing diminishing supplies, areas that are not flood prone, and areas that are already relatively well prepared for the disasters at hand. So hardened against things like high winds, power interruptions, things like that. There's a lot of groundwater systems in the Midwest, the Great Plains of the United States who probably more or less meet this very low percent need to be spent on climate change resilience. On the flip side, there are some systems out there which probably needed to spend a very, very high percent of their capital improvement dollars on climate change resilience. Some of these might be coastal communities with water supplies that are at risk due to sea level rise, and infrastructure which is at risk due to sea level rise. If there is saltwater intrusion on groundwater supplies, would also necessitate spending a lot on resilience, possibly. Another one might be an arid community that's in a location where there's very, very intense water supply competition. So think parts of the southwestern U.S. maybe, and that may have infrastructure exposed to increasing wildfire risk. So this is really going to be dependent on your site-specific characteristics of your utility and the environment in which it operates. However, all systems should consider spending to mitigate climate change. Many energy efficiency projects within the water utility sector are very favorable investments, and you're also reducing, carbon pollution at the same time. So that's kind of a win-win. So hopefully that helps answer that a little bit. The other thing I would stress is that resilience is not just capital spending. Resilience has a lot to do with employee training, preparedness, having relationships with local emergency responders, having plans on the shelf that have been practiced and are ready to go in case of certain disasters that may be made worse by climate change. So before you go and spend tens of millions of dollars on climate change resilience, you might ask yourself some questions. Is our system well equipped for the current threats we're facing? Have you talked to your local emergency managers, your first responders? Do they know where your infrastructure is? Do you understand their assumptions about you? So establish those relationships with your local emergency managers, your fire department, and other folks that will be involved in disaster response. And it's also important to note, resilience is also planning and staff education, and I would probably extend this to, particularly areas that are drought prone, customer education and customer involvement efforts. With that, those are the questions I was able to answer from the registration, and I would like to note that we are able to provide you with no-cost technical assistance if you are a U.S. water utility serving under 10,000 people. Feel free to contact me directly, or also you can go through the EFC network. The website is posted here to request assistance. With that, I'd like to turn it over to Tess, and she'll see what kind of questions have come in during the call itself.
Great, thanks so much, Nick. Yes, we are getting a couple questions, and if you are still thinking and you want to submit one, please go ahead and type those in. We still have a couple minutes that we can spend on this, so so go ahead and type them in if you still have questions. But the first question that we got is basically, what is O&M? So if you could go ahead and tell us what O&M stands for and just some good examples of the activities that you might do to rehash that.
Yeah, sorry about putting an acronym out there without defining it. O&M stands for operations and maintenance. So don't remember what slide this was on. I think it was looking at the spending, where you spend money on things like maintenance of your capital assets out there in your utility network. So operations expenses typically are more or less fixed. They're your employee labor, energy, chemical costs, things like that. The big decider when it comes to looking at your critical assets is your maintenance expenses. So kind of a very extreme example, almost all water utilities have things like lawnmowers and weed whackers and things like that. These are very cheap. And you can spend a lot of time maintaining them. They're often kind of have finicky carburetors or, need blade sharpened, whatever. So you have a limited amount of time, money, and material resources to put into your various assets. Almost every utility, and I'll go back to the slide here, has these very low importance level assets. So when you're looking particularly at your maintenance budget, are we spending a lot of our maintenance dollars and our maintenance material cost on the low important assets or the extremely important assets? One of the ideas drawn from asset management is to take that time and money that's being directed at those assets that if they fail, it's really not that big of a deal, and putting it towards those things that if they do fail, it's a big deal. So we're going to try and ensure long life, that we're near those assets when they're operating so we can hear weird noises or smells, or that it's putting out more heat than normal, that something might be amiss with it. So spend less time on your push mowers and more time on your high service pumps, for example. So hopefully I've kind of answered that and how it interplays with capital improvement planning. I guess I can take to the next question.
Perfect. Okay, great. So the next question is, switching gears, completely different direction, but why do you recommend a separate equipment replacement plan?
So the main idea here is that a lot of your equipment is kind of a must-have. So let's say you have a well. You know that there's a pump and a motor attached to that well, maybe some electrical switchgear, and at some point it's going to fail. And oftentimes the well, again, depending on system characteristics, would be a fairly high-risk asset if it were to fail. For particularly smaller utilities, often don't have a whole lot of redundancy on that sort of thing. The idea with that is that this is money I'm going to have to spend at some point. There's really no getting around it. Your capital improvements are generally a little more discretionary about when you get around doing it and what kind of scope you have. So your well, if you have a 15 horsepower motor, 20 horsepower motor, whatever, that's pretty much what you're going to replace it with. So the idea that you would save separately for that equipment you already have is basically there to ensure that this stuff that has relatively short lives, maybe less than, somewhere between 10 and 20 years of life expectancy, the money will be there when I need it. The capital improvements are things that you might only do once in your career as a utility manager or a utility operator. So if I replace the water line on Oak Street, the next time it's replaced, more likely than not, I'll be dead. So these are things that, are typically much more involved, things which you often have to get outside financing for. The other reason to have an equipment replacement plan is to have money ready to go when you need to replace. So you're setting aside a certain amount of money in equipment replacement so that when that pump goes down or you need to replace the operator's truck, the money is there when you need it. So it's kind of like an ongoing savings thing. And if you're interested in this, again, feel free to contact me. I think it's pretty valuable to have an equipment replacement plan. The other thing with equipment replacement, if you don't have a plan, it is a good way to illustrate to board members and customers, look, just to maintain this stuff that's not our pipeline, that's just like, our pumps and our vehicles and our tools, this is what that costs a year. And if you ignore that cost, you begin to fall behind, just like, ignoring maintenance will cause problems. Ignoring equipment replacement in a timely manner will also cause problems over time.
Great. So we just got a couple more questions. So this one is a little bit longer, but it basically goes like this. The system is building a mechanical wastewater plant, and the engineers have not put in any costs related to sludge disposal. But this will be a high cost after, through energy or even after an emergency. And the question asker wants to know, how do I get my board to look at this?
Yeah, that's a good question. Yeah, I did talk earlier about those ongoing operation and maintenance costs. So this is an operation cost. Wastewater treatment plants produce waste, sludge. The water typically goes out into the local creek, and the sludge has to be dealt with. And the way it's typically dealt with is either it's land applied or it's landfilled. Both of those will have some cost depending on your local area, and also the quality, like the chemical qualities of the sludge. You may be pushed towards land application or landfilling as far as which cost is less. As far as getting your board to look at it, I would recommend contacting some of your neighboring communities with mechanical wastewater treatment plants and ask them what their annual sludge disposal costs are. And they're going to account for it a little differently, but they would probably be helpful in telling you how many labor hours it takes to do, what kind of equipment they have to have, or what their landfill fees or solid waste fees are. And I would put that maybe on a per person basis or something like that to kind of equalize them. So you're somewhat comparing apples to apples. But you're right. If that's not been accounted for in operation and maintenance cost, that's going to have an impact on ratepayers, and you can't just not deal with sludge. You'll eventually run out of space, and you'll be, an inspection will find you in non-compliance with handling it, and there will be other consequences. So, good question. I would reach out to nearby utilities or potentially the state level, Water Environment Federation or Rural Water Association often does wastewater stuff as well, and they can give you a good idea. But yeah, that's a good due diligence on looking at what your consultants are doing there.
Great. Okay, so we actually have another sort of similar question. This question asker says that she could use help raising awareness among board members and shareholders to start funding a capital reserve. And up until this point, they haven't done a CIP, just ad hoc repair and replacement. So do you have any experience or advice for how to communicate the importance of funding a capital reserve to stakeholders and board members?
One of the other people who's part of the EFC network, the Southwest EFC, kind of put together a high-level estimate of like system value. So it takes like, the size of pumps you have, the miles of pipe, the size of storage, and I don't recall everything else on hand, and says, if you were to replace all of this tomorrow, this would cost you $2 million. And it's very, very rough estimate. But oftentimes, particularly with buried infrastructure, we don't realize what we have and what the cost of it is to replace over time. So let's say you have $2 million of estimated replacement cost. And then you can look back over your last few years of capital spending and if you're spending $20,000, I'm doing bad math here. Yeah, if you're spending $20,000 a year on that, that would be about, that would be going on the assumption that all of your stuff is going to last 100 years. And that may be reasonable for some of your storage, some of your pipeline in the ground, but it's probably not reasonable for your well pumps, for your high service pumps, for your water meters in your system. And so it can kind of give you a good idea of, at the high level, I know I should be having assets somewhere in the maybe 50-year lifespan, maybe somewhere between 50 to 100-year lifespan. And if your historical spending is far less than that, that can be a good wake-up call to your utility folks. Another thing you could do is begin with equipment replacing. So take all of that moving equipment, so things like water meters, vehicles, pumps, pressure-reducing valves, things like that, and figure out, what kind of inventory of those assets you have, and put some estimates to life, and see what you're spending on just those assets that are going to have relatively short lives, and if you are even reasonably budgeting to replacing those. It is very, very easy to delay equipment and capital expenditures in a water utility system. Broadly in the U.S., that's a lot of the reason why we have quote-unquote crumbling infrastructure, because it's easy to delay. You don't replace a water line this year. More likely than not, it'll still be in service next year. But eventually the level of service decays over time that you end up having to replace it. So yeah, feel free to reach out to me after this webinar, but that's a good question. You can do all the capital improvement planning as a staff, but if you don't have board understanding of what's going on, it's not going to do any good for your utility or your utility customers. So that's a good question.
Yeah. On that note, I think it's a good time for us to, we do like to ask everyone on the webinar a quick question about technical assistance. Like Nick mentioned, we provide technical assistance to water systems, primarily those serving 10,000 or less people. So if you know that you have a need in this area, or you could use someone like Nick to help you look at estimates or to help you look at the beginnings of your CIP, this is a good time to tell us if you'd be interested, and someone can reach out to you. So we're just going to give you another couple seconds to just respond to our poll, and if you say yes, then someone will reach out to you to check your eligibility and match you with a good expert. Okay, looks like almost everyone has responded here, so I'm going to close this. Thanks for letting us know. And I also want to draw your attention quickly to the chat box. I'm going to send out a link to our survey. This just helps us get good feedback for our webinars and helps us improve. So if you want to go ahead and take that, feel free. And on that note, Nick, we're at the very top of the half hour here, 3:29 Eastern. Do you have any closing comments or anything else you'd like to add about capital improvement planning for today?
No, it is. It's a very valuable long-term planning tool, and your utilities are going to be there much longer than you will be working there, and hopefully they're around after we're no longer around. So let's try and do our best to keep them functioning well and providing good service to our customers.
Great. Thanks, everyone.